This meeting is being recorded.
Okay, very good afternoon. So in this semester, I'm going to deal with the subject CMOS VLSI design for your division. Okay, am I clearly audible?
Yes, sir.
Yes, sir.
Okay, so we will start with the introduction of the subject, then its prerequisite, then course objectives, course outcomes, then actual syllabus, what different points that we are going to discuss in this particular course, then textbooks and reference books, and as this subject is having practical and practical oral examination, so we have to go for practical for this subject. So we are going to discuss the list of practical also. Okay, so let me start with the presentation. Okay, screen is visible.
Yes, sir.
Okay, so subject is CMOS VLSI design. Subject code is ET422. As far as the teaching scheme is concerned, you have a 4-hour lecture per week, which carries 4 credits, and practical of 2 hours per week, which carries 1 credit. Okay, and about examination scheme, so uh, you will be having the ENSEM examination, that is ESE, for 70 marks, right? If the examination will be offline, probably in this semester there are more chances to be offline examination for at least final year. So there will be a 70 marks written paper and you have to appear for that. And if it is online, then as usual, you know the things, you have to solve 50 MCQ question, right? And that 50 marks will be converted to a 70 marks, and your final result will get displayed. So that is about ENSEM examination. For ISC, there we are conducting actually 3 ISCs in offline mode, but now for in case of online, we are conducting the 2 ISCs, ISC1, ISC2, that carries total 30 marks. Okay, that will be also considered in your uh, final for the calculation of your final curriculum marks. This subject is having practical oral examination of 50 marks and term work, that is internal continuous assessment, for 25 marks. So this is about the examination scheme for this particular subject. Here is my introduction. So, okay, so uh, many of your classmates or many of students from this class is familiar with me, as I have taught them the optical communication subject. For those who are not familiar with me, my info is given onto the slide. You can save this for your communication purpose to me with me. Okay, so we will start with the vision and mission of our institute. Okay, what is vision of our institute? To be nationally recognized amongst the best institute in India for excellence in technical education. Okay, so now as far as we are appearing for the NAC accreditation. So maybe in uh, last week of this month or first week of next month, that is April, the PA team may come to our college or may visit our college, and he can ask any of you or even me, what is the vision and mission of your institute or department. So all of you must at least have the know you must know what is the vision mission of the institute and department. So I request everyone to go through it properly and try to get the notion of our vision and mission. Okay, so about our mission: to impart value added technical education through ambience of academic excellence, research and life skills by inculcating personal touch and respect in a relationship amongst the stakeholders. Okay, who are the stakeholders of this institute? You, me, right? Employers who are providing you the job, parents indirectly. Okay, so we all are the stakeholders of this institute. Okay, so this is about the vision and mission of the institute. Now our department, as you are going to complete the graduation from the faculty electronics and telecommunication engineering field, so our department has our own vision and mission. Okay, so this is department vision and mission. What is vision of our department? To be recognized for excellence in education in synergy with research in the field of electronics and telecommunication engineering. What is mission? To impart value added technical education by nurturing the culture of collaborative research, innovation and term work by imbibing mutual respect and human values. So this is the major vision and mission of our department. Okay, this is the as you know, you are currently undergoing the CBCS, choice based credit system. Okay, so this is a syllabus structure, overall syllabus structure. So in this semester you have these many subjects and these many laboratory courses. Okay, and its credits, then examination scheme, and the number of lectures, tutorial, practical, whatever it is given in this table. Okay, you can get this in your syllabus copy also. Now coming to the short introduction of this subject, that is CMOS VLSI design, what actually we are going to study in this particular course. So in this course actually we are going to introduce how to design, how to simulate, and how to test different digital logic circuits, right, which is designed using CMOS logic, right? What is CMOS? Can anyone?
It is
MOSFET
combination of PMOS,
and its combination
PMOS
of
and
PMOS and
PMOS and
NMOS.
yes,
NMOS. NMOS, right? But what is a full form of CMOS?
complementary metal oxide semiconductor.
Right. Very right. So in this subject, we are going to study every single design simulation of different logical circuit, that may be a adder, that may be a multiplier, that may be a ram, rom. Okay, so basically we are going to study its design of different logic circuit. That means it may include some combinational logic circuit, it may include some sequential logic circuit. So basically we are going to study that design by using CMOS logic only, right? And it's a combination of uh, PMOS and NMOS. PMOS is acting as a pull-up network, NMOS is acting as a pull-down network, right? And when you connect that PMOS and MOS parallel to each other, that forms the CMOS. Okay, it may be a parallel or it may be a serial, depend. But uh, a single CMOS transistor must have pull-up network as a PMOS and pull-down network as a NMOS. Okay, so I hope this is clear with you. Then talking about the next introductory part of this subject, basically it describes different design of sequential logic, combinational logic, different timing issues of any digital circuit. See, when you are going to design and simulate any digital circuit, okay, any digital, that may be a combinational or sequential, doesn't matter. I hope you have well aware of combinational logic design and sequential logic design. Can you just brief it, what is combinational logic design and what is sequential one?
Sir, combinational does not have memory unit in it, and it is only
Mhm.
work on present input. And in
Hmm?
sequential, it has memory unit and it work on present input as well as the past output.
Very right. Okay. Now I hope you have through it. Combinational means what? The logical circuits which don't require any memory element, right? That is combinational one. And what about sequential? Sequential must has some sort of memory element, right? And normally, as you know, in digital design, what kind of memory element we are using? Preferably data flip-flops, D flip-flops, right? D flip-flop will act as a storing element or a memory element, because D flip-flop has a capacity to hold a particular logic bit and even to transfer to the next stage. So that's why in most of the cases, D flip-flop we are using as a memory element. Okay, and it's different timing issues and its implementation part. So this is why this is about very short introduction of this subject. Okay, now next is a course prerequisite. Means what? Before going to study this course, you must have a basic knowledge of digital devices. You must clear with the what is difference between the combinational and sequential logic design. What are different types of testing and simulation tools that you can use for this. So these are the some course prerequisite, right? So that you can have the better understanding of this subject. Now, coming to the course objectives. Okay, means what? While studying this entire course of CMOS VLSI design, what are its objectives? Why it is included in your curriculum? So, first objective is to make student learn EDA tools for a CMOS logic design and simulation. This is the first objective of this course. Second one is the to enable student to design CMOS logic based design modules for a combinational logic circuit. Third one is to enable student to design CMOS logic based design modules for sequential logic. First one you must able to design CMOS logic for sequential logic circuits, and second one is as for sorry, first one is for combinational logic circuit, and second one is for sequential logic circuit. And the fourth course objective is you must able to acquaint different timing issues, different arithmetic and memory modules, such as you have ALU, arithmetic logical unit, SRAM, static RAM, there, DRAM, dynamic RAM. So all these are the memory modules, and it's testing. Okay, so these are the very broad course objectives. Okay, Now, this is very important. We will talk about the course outcomes, right? First one is a course objective, means what, why this course, or what you are going to learn, right, in this course. That is the course objective. Now, course outcome means what, after learning this course, what you are going to get out of this, right? That is the course outcome. So what you are going to get out of this, first, you must able to describe MOS transistor theory and mathematical equations for its behavior of E-MOSFET. Okay, what do you mean by E-MOSFET? Enhancement type MOSFET. Okay, now second outcome is you must able to illustrate different design rules and layouts for MOSFET. Third, design combinational logic circuit using eMOSFET. Fourth one, design sequential logic circuits using eMOSFET. And the last CO or course outcome that you have is analyze timing issues in digital circuit. Okay, so these are the 5 course outcomes that you should remember. That you should remember. Okay, uh, or that you should able to what we can say able to grab after learning this course. Okay, now we will talk about the syllabus. So we have total 6 unit. Section 1 covers the 3 unit and section 2 covers the remaining 3 unit. So in unit 1 is a MOS transistor theory. In that, what we are going to discuss, physical structure of MOS transistor, then accumulation, depletion and inversion modes, then MOS device, its design equations, right? So as you might have studied the MOSFET in your second year ECAD subject, right? Uh, you have studied, I think in your second year ECAD subject, you have entire 1 unit, MOSFETs and FETs and MOSFET. Am I right?
Yes, sir.
Yeah. So in that already you have studied this basic part. In that you have studied different layers of MOSFET, then its VI characteristics, different types of MOSFET, enhancement type, depletion type, all that. Okay. So the first unit may be a repetition of that only for you. New part is a technology scaling, then static and dynamic behavior of CMOS inverter, then power and energy delays impact of technology scaling on inverter. So what is inverter and all that, that may be a new part. So this is all about the unit number first. Okay, now coming to unit number 2, that is the circuit design process. In that, what we are going to discuss, MOS layers, then stick diagram, design rules and layouts for this stick diagram, lambda based design and other rules. Okay, so this is what we are going to cover in unit number 2, that is circuit design process. Now third unit going to cover combinational logic design in CMOS. Now we are going to design different combinational logic circuits using CMOS. Okay, so in that first point is a static CMOS design, that is complementary CMOS, implementation of Boolean expression using CMOS logic, then uh, rationed logic and pass transistor logic, then dynamic CMOS design, dynamic logic basic principle, speed and power dissipation, issues in dynamic design, cascading dynamic gates, comparison of static and dynamic design in CMOS. This all these points are going to cover under this unit number 3, that is combinational logic design. Now unit number 4 will talk about the sequential logic design in CMOS. Okay, in that what we are going to discuss, static latches and resistors, then bias stability principle, multiplexer based latches, master slave age triggered resistors, then low voltage static latches, static SR flip-flop, dynamic latches and resistors, dynamic transmission gate, age-triggered resistors, then C2 MOS, then different clock skews issues, insensitivity approach, true single phase clocked resistor, that is TSPCR. Okay, so all these points we are going to cover under unit number 4. Now unit number 5th is the timing issues in digital circuit. So all of you know whenever we talk about any circuit, that may be a analog one, that may be a digital one, but every circuit has some delays, right, to transfer input towards the output, right? Different kind of it, the signal has to go through different modules, different electronic components. Again, wire has itself its own propagation delay and all that. Similarly, in digital circuit also, when you talk about a signal propagation, that means from input towards the output, that involves some sort of delays. Okay, and this particular unit is going to talk about different timing issues, that means nothing but delay, that are involved in the digital circuit. Okay, so what are different points that we are going to discuss under this unit? Timing classification, synchronous interconnect, then mesochronous interconnects, then plesiochronous interconnect, asynchronous interconnect. There are different types of interconnects that we are going to discuss. Then what do you mean by jitter? What do you mean by clock skews? Then what are how actually clock distribution should happen in while designing a digital circuit? Then latch based clocking system, synchronizers and arbiters using PLL for clock synchronization. So all these different aspect of the timing issues we are going to discuss under this unit number 5th, that is timing issues. Now the last unit, unit number 6, it is designing arithmetic and memory building blocks. So in that we are going to discuss the CMOS design. Okay, again I will repeat, in this we are not going to discuss anything about the actual using logical gates. Okay, here we are going to design everything using CMOS transistor. Okay, so designing of fast adders, multipliers, then ALUs, ROM, DRAM, SRAM. So all this sequential logic designs we are going to discuss again, or you can say it's advanced application of sequential logic design that we are going to discuss in unit number 6, that is designing arithmetic and memory building blocks. Okay, now these are the some of the suggested list of practical that we are going to perform using some simulation tool, design of CMOS logic design, then logic gates using CMOS, then universal gates using CMOS. See, remember, in this practical, we are going to design everything using CMOS only. Then half adder, full adder, then half subtractor, full subtractor, multiplexer, demultiplexer, latches, flip-flops. So these are the some of the suggested practicals, and we are going to perform using some uh, simulation software. Okay, so this is about the list of practical. Now for your reference, you can refer this textbook. Okay, uh, it is most of our syllabus will cover in these two textbook. Once I will share with you the study material link, you will find this textbook in our study material link. I will share most probably very soon. Okay, and these are the list of references. You can refer these books also. And if you want to have the more book on this particular course, CMOS logic design, so there are many free downloadable ebooks available on internet. You can Google the particular book name and you can get its ebook. Okay, and that you can download for free. So these are the reference book. I hope this is the basic introductory part, and we have discussed different aspect of this subject course, its examination scheme, credit scheme, and all that. I hope you are through with this. Okay, so for today we will stop here. In next lecture we will start with the actual first unit or actual syllabus, unit number first. Okay, if you have any query doubt, you can raise your doubts right now. Anyone
No doubt,
have?
sir.
Okay, fine.